Okay, we should be live now. One moment. Okay, hello there everybody. This is Genesis here, another live stream. It is actually 9. It's about to be 10 in the morning for me. Um I have to whisper. I don't know if this counts as whispering, but I can't be very loud. I have 2 hours to stream. I'm trying my hardest not to be really loud right now. And yeah, because there's people sleeping in my house right now. So please bear with me. I usually don't really uh talk this quiet. But yeah. So we're going to get into the topic of uh I don't know. I guess I'm just going to do a quick little update on what's been going on my channel, and I have some good news and some bad news. The good news is that I've been learning a lot of cool stuff, and I've been making an archive of all of the workflow and stuff that I've been doing and learning recently. And it's on my YouTube channel. I recently made a YouTube channel. As you guys know now, I've been doing this. You guys can go back, rewind, see my workflow. But the most important part is that I'm doing this more importantly for documentation purposes, if that makes sense. So I can go back, look back, and see everything that you're seeing is me learning in real time. So uh, I don't do this professionally. I'm an underground, self-taught programmer. Everything that I do is just learned by myself. First off, I hope everyone's having a great day. But yeah, we're just going to get into some of the news that I have to say. First off, I'm proud to announce that I'm fully transitioning over to YouTube. That means that if there's anybody who watches my streams on Twitch, I won't be streaming on Twitch anymore. I've made the move over to YouTube now. I don't know. I just like it better. I feel more comfortable on YouTube, not Twitch. Sorry, and I'm enjoying my time on YouTube. Just going back and looking at like my live streams, and you can do that on Twitch, but the versatility, the best way I can put it is when you're streaming on Twitch, the categories, the communities are very tight, right? It's not like YouTube. It's a grand scheme of people. It's like, really a lot, there's like thousands upon millions of people that you can reach out to. Whereas the software development category and the science categories on Twitch, there's like at least 100 to 1,000 people. That's really it. And once you've made your impression on those 1,000 people, they're going to hold those impressions for you. Here's some news, you guys. Those categories the software development category does not like me whatsoever. I don't take it personally, but if you show a lot of drive and you're very passionate about what you do and you're a small creator, you're not going to be doing well over there. So my best advice to anyone who wants to actually start doing like software development and you don't really have a reputation for it, get on, start a YouTube channel. Yeah, but with that said, I guess we can just go on and talk about what I have planned next. So I won't be on Twitch anymore. We're making the migration over to YouTube, and I'm going to be on YouTube permanently from now on. So there is that. I tried to get streaming for Twitter set up, but I couldn't get it to work. Anyway, let's continue. So, what have I been learning recently? As you guys can tell, I've been really into neural networks recently. I've been really dabbling, getting my feet wet with neural networks. And I find it very fascinating because, the capabilities of neural networks are just amazing. Just being able to see how things work, how artificial intelligence work, stuff like that. And I didn't even come in to wanting to do neural networks or anything like ANN. I just wanted to learn some simple object detection, and object detection. It kind of went on to what's it called? Artificial neural networks, because that's how object detection works. It works through these neural networks where the detectors go, you know. So it just fascinated me. I'm going through rabbit hole through rabbit hole through rabbit hole, and I'm having a really great time, you know. Um, but I'm going to pull up something here. When it comes to programming, mathematics plays a big part in code. I'm starting to see. Well, I knew that already, but in the sense of neural networks, they make a lot of sense. They're really important. The reason being is because every artificial neural network, the neurons, or you can call them the perceptrons, that are actually handling the weights and the vectors, they actually work with coefficients, and there's like, you know, the inputs are values, and you kind of have to, there's formulas for all different types of activation functions, and these activation functions contain arithmetic, and this is kind of how it's going to be doing its type of learning. Let me show you. So try not to pay attention to all of this stuff here, but long story short, this is just a bunch of compiled information that I do, that I like put together, so to speak. I use Obsidian for taking notes. I don't really use anything else. It's free and it works for me. So there's that. But if we make our way to this over here, activation function, we have all this information here. So first, I'm going to read this documentation to explain what an activation function is. But before we get into that, I want you guys to know that artificial neural networks are just genetic mock-ups or makeups of the actual human brain's neural network. We're trying to reverse engineer and actually downplay and actually recreate it. And we're doing a pretty damn good job at it, right? So these activation functions, there's different types of activation functions. There's the sigmoid function, and here's its formula. And as we can see here, it's using, you know, to the power, it's using addition, it's using variables, it's using all different types of arithmetic elements inside of the formula, right? The output range, the smooth, this is kind of like the algorithm that it's using. And then every single activation function within an artificial neural network, they all have different things they're good at and things that they're bad at. And if we look here, let's go read the first one. So we have 5 in total right now that I've learned so far. I haven't went full on depth and actually learned them. I've learned that their functions. All I know right now, as of May 19th, 2023. By the way, it is May 19th, 2023. It is 10 in the morning right now. It's about to be 10:08, and I have to go to have to be somewhere very soon at around 12. So I have like around an hour and a half to actually stream. So yeah, this is going to be kind of a short stream, but we're just going to be breaking down all this stuff here. So why is this stuff important when it comes to programming? Yo, I can't say this enough. It is really important because without ANN systems and networks, you really wouldn't have object detection. You wouldn't have uh, tracking. You wouldn't have a lot of the things that we have in the world today, like face recognition on your phone, um, just artificial intelligence, period. Because when we're talking about artificial intelligence, we're talking about the network, where it all starts, where it all begins. So the network is where it all begins. And this neural network, this artificial neural network, will um, compare data sets together, and it'll make training data, and then after the training data, it'll go through the test phase. And once it does the test phase, it's going to check for its predictions. It's going to try different predictions and outcomes. So there's a lot of stages that comes inside of a artificial neural network. There's a lot of stages that come with it, but we're going to just focus on this one for now. So as you can see, an activation function is a mathematical function that is applied to the output of a perceptron or an artificial neuron to introduce non-linearity. I don't know how to say that. I think I said that wrong. So what does this mean, to introduce non-linearity? When something's linear, it's predictable, right? So there's different types of transformations. If we make our way over here, I've done my studying on this. If we go all the way up here and we go to transformations, there's linear transformations and there's non-linear transformations. So this is what a linear transformation would look like. Here's like a picture of a linear transformation inside of an artificial neural network. I'm going to kind of make it a little bit smaller so you guys can see the whole thing. Yeah, so that's what it would look like. I'm actually going to make it a little bit bigger. Yeah. Yeah. And then we have nonlinear transformations, which are these. As you can tell, there's a big difference, right? Nonlinear transformations, they vary. They're way more complex. They have a lot of twists and turns and different types of they're very more complex. They try a lot of different algorithms and routes and paths to get an actual prediction. So all you need to know for now is that there's two types of transformations. There's nonlinear and there's linear, in a sense of ANN. We come back over here, and then there is, and determine whether the neuron fires or remains inactive. So after all of this, the transformation, it's going to decide whether the neuron is going to decide whether to fire information or whether to stay inactive. It transforms the weighted sums of inputs plus the bias into an output value. So here are some commonly used activation functions here in neural networks, right? And you could really say this is still happening in biological neural networks too. This is actually happening in your brain too right now as we speak. How you're compiling all this information, you should thank your neurons for that, because they are actually data transmitters. They transmit data throughout your brain. They're part of the nervous system, and they are responsible for the cognitivity and the motor skills that you have daily, like walking, opening a door, stuff like that. These are tasks. These are tasks, right? So why would we want to replicate this as a programmer? Because as a programmer, maybe we want to create a program or a robot that can open up a door, have its own artificial cognitive system where it can actually analyze and make its own assumption and learn as things go by. Yeah. All you need to know is that artificial neural networks are just a huge ass mathematical convoluted intricate process. It's a very intricate. I myself am still studying it. So this is going to take days to learn. Artificial neural networks is not something you're going to learn overnight. So don't feel like you have to learn this. But yeah. So this is the sigmoid logistic function. So let's actually look up an image of this and let's see what this looks like. This is what this looks like here. So this is a sigmoid I don't know how to say this word, excuse me. Logistic, there you go. So this is what this would look like. As you can see, it has like this S curve going on. And then we have some more here. Here's another one. This is another sigmoid function. Has this S curve that we're seeing that we're so prominent about. Let's make it a little bit bigger. So what is this? What are we looking at? What does this have to do? These are the activation functions within an artificial neural network. And there's different types. That's all you need to know right now. Don't think about it too much. Don't get too complicated. These are just different algorithms for the activation functions. Now, every activation function has a formula, an output range, and a certain shape, and they all are good at certain things. Each one of these each one of these 5 are good at their own tasks. The sigmoid function was used in the past, but less common now due to vanishing gradient problems. So this one isn't used that much. The hyperbolic tangent function is used in certain cases where output ranges from -1 to 1 is desired. Rectified linear unit, or known as ReLU. Precise linear function that outputs input directly if positive, otherwise 0. Widely used due to computational efficiency and avoidance of vanishing gradient problem. So rectified linear unit is used quite a lot when it comes to activation functions. And here's its formula right here. It doesn't look as complex, but it's all the other ones. We have the leaky ReLU and migrates to dying ReLU, problem where neurons become inactive. Similar to ReLU, but allows a small gradient when x is less than 0. And then we have softmax. We have this type of activation function. And here's the formula to that. And what is softmax good for? Primarily used in the output layer for multi-class classification problems. So this would be more so used for multi-class classification. And then we have converts a vector for real numbers into probability distribution. So I'm going to write all of these formulas down for you guys and for myself too, for future reference if you want to know what they are. So we're going to put this. So this is the formula for the sigmoid. This is the formula for the hyperbolic tangent. And this is the formula, and so on. Everything else that I'm going to be putting here is going to be the formula for everything else. I don't think I got sleep. I think I did sleep last night. I did. And this is what I love about YouTube. You can actually you can save your stuff. Did we put the rectify linear, and then we have the leaky? So what I'm putting down right now are all the formulas for activation functions within artificial neuron networks. These are the formulas themselves. And why you should know this is because later down, when you start writing your own neural network, you kind of have to decide on what type of formula you're going to use, because it's really super essential, because the formula that you use is going to really drastically impact on what the outcome is going to be, if that makes sense. So after the formula, after you see formula, yeah, you should know what they are. You should be doing enough studying at this point. Okay, so we have 1, 2, 3, 4. This top one, formula, I don't know what that formula is for. I must have gotten the hyperbolic. Let me get this one again. I don't think I put this down right. Just in case. Here's the hyperbolic. There we go. Now we have all of them. Yeah, just go ahead and go search through that, and yeah. So now that I've explained this, we can actually continue. The choice of activation function depends on the desired behavior and the nature of the problem being solved. What does that mean? That pretty much means what the documentation is trying to say. The choice of the activation function that you choose to use within your ANN is crucial, because it depends on what type of task or problem you're trying to solve, or you want your neural network to solve and be dealing with, right? Whether it be with dealing with images or dealing with video data, you kind of need to know what correct activation function to be using. And yeah, the people who actually know this stuff take their time to really analyze every single thing about this stuff. They're very, very, they've taken the time to really study everything here. Okay. I do want to say this. As long as you study all of this documentation, you should be fine. You're going to fail. You're going to have to start actually making your own neural network. And I am proud to announce that probably today I'm going to, or maybe sometime this week, I'm going to be making my first small neural network, something very simple, something that processes, you know, like an image like this, letter blocks, an image like this, and it can actually return me all of the letters that are inside of the image of any image. So I could go to Google and feed it this, or feed it that, or feed it any of these, and even numbers. Like the neural network will be able to tell me, well, this is A, B, C, D, 1, 2, 3, 4. These are the values that I found, you know? Stuff like that, you know? Even images like this too. Right? And remember, neural networks is how we process the world. That's kind of the reason why we want to implement them. And even with this cat image here, you see this little, I don't know if you guys can see that. I'm going to make this bigger. But do you see this little cat drawing here? A neural network would be capable of actually detecting if that's a cat or a dog. The capabilities are there. It's amazing and it's astonishing what you can do with this stuff, right? So don't fret. Just practice makes perfect and you'll get there. But I want you to just practice on these blocks here and maybe try making your own neural network, a small one that can handle imagery like this, maybe with some object detection going on that can actually detect stuff. But definitely study activation functions and all that stuff. Because as you guys can see, I'm not just saying I'm going to make a neural network without information. I've read everything here from coefficients to SVMs, which means support vector machines, to like what else? It's a convolution, regression, coefficients, faster NN, all this stuff just by looking at this stuff. The more consistent you are with practice, the better you'll be. Exactly, sweetie. Exactly, sweetie dolls. Exactly. So that is Mrs. Genesis. That is my girlfriend. She's amazing. And I'm sorry, my love, if I'm sitting here talking to myself, but I'm just explaining this rubber duck debugging before I have to go. Because I have to leave at 12. 12 or 11. Yeah, but with the more practice you do, the better. I can give you more of an example. My goal, my long-term goal is to, one of my goals are going to be to make a artificial neural network known as ANN. And if you don't want to say artificial neural network every single time because it gets annoying, you just call it an ANN or an AN. So I'm going to make an AN that is capable of actually taking image data sets and analyzing these data sets and through its weights and its vectors to give me a desired output, whether to tell me what lettering is inside of these images on these blocks. So if I have this image here, like maybe this is a data point inside of my data set, this counts as a data point, and my neural network will be able to just tell me, well, this is the letter A. This is a block that holds the letter A. Now, to make it that it can do that, that's going to be even more. But I want you to understand that once an artificial neural network gets going and you build it efficiently, the rest is history. It's going to start learning on its own. It's going to start making these assumptions. It's going to compile this data, and it's going to be able to predict data that hasn't even existed yet. Yes. Artificial neural networks are capable of even predicting data that's not even, assessed yet. And data that's already inside of the, that's going to be inputted. So long story short, neural networks, even your brain, in the grand scheme of neural networks, they take inputs, and these inputs are data sets. Doesn't matter what it is. It could be auditory, visual, in the sense of a human being, sensory, like feeling something, like when I touch this, like if I close my eyes and I put my hand over my mouse and I feel it, this is the input data that I'm getting, and I know that this is a mouse in my right hand. It's the same shit. It's literally the same shit, and that's kind of how artificial neural networks work. It's to understand their environments, a way to understand your environments, if that makes sense. I have to go soon, my loves. I wanted to catch you before you left. Okay. Explaining will give a better understanding. Exactly. Exactly. Yeah. And I'll definitely catch you soon. When you come back, my love. Um, I'll be here, studying this shit. So that's what I do. I love studying this stuff. But I hope you have a great day at work. And because I gotta go at 12. I got somewhere to be. I got an appointment. So okay. So let's go back to where I was before. If I can find it. Activation functions. So if we go here, activation functions use basic mathematical operations such as exponentiation, addition, subtraction, division to compute their results. That's right, ladies and gentlemen. You only have to have a sense of exponents, addition, subtraction, and division when it comes into the grand scheme. I mean, there's probably more, right? But a neural network uses basic arithmetic, basic mathematical principles to actually get its output with certain functions. So the sigmoid function utilizes the exponential function and division. The hyperbolic tangent or tanh function involves the exponential function, subtraction, and division. The rectified linear unit employs the max function, which compares two values and selects the larger ones. Okay, so you could see why the rectified linear unit is used more, right? Because did you just see what they just said? It compares two values, whichever is the larger one is the one that it chooses. So it's a little bit more simple in a way. It uses a more efficient method to catch things. And then we have the leaky rectified linear unit. Similar to the other one, it uses the max function and multiplication. And then we have the soft max function, which includes exponentiation, addition, and division. So it's utilizing all of these. So each function is using different arithmetic to get a result, but it doesn't matter. They're processing information, but their end results to all 5 of these is to get a final output, to get the best output that they can possibly get. Some are better than others. That's all you need to know. We don't need to complicate this situation. I'm telling you, as someone who's studying this stuff for fun, who sits there hours and hours and hours and hours. Some people go to school for this like 5/10s, and then they just tell me what the fuck their teacher tells me. No, this stuff is more complicated than even what your teacher's telling you. This stuff goes really in depth. I had this one guy come into my stream and try to tell me something, and he ended up being wrong on something. So be very careful when you try to learn this stuff. And if you're one of those programmers who likes to really study every little intricate part of something, then give yourself on a pat on the back, because that's going to give you the cutting edge to making something that is high quality code, a high quality system, an integrated artificial intelligence within your computer that is capable of doing great things. But remember, with a lot of knowledge comes a lot of responsibility. Just remember that. I don't think I have to say why. Some people could use this stuff for bad. You could ultimately make an I'm not going to get there, but let's just say this: social security numbers, credit cards. Yeah, it could get to that point, but I'm not going to be showing that on my stream, right? We're not going to be getting how to steal people's information on the internet. Not going to do that. If you want to learn how to do that, go to a deep web website. I don't fuck with that shit. You know, if you're a hacker and you do that stuff, then, you know, honestly, I think if a hacker does that stuff, I don't really think there's anything wrong with it. It's their life. I'm not going to judge a hacker for what they do. Everyone has reasons to do what they do, right? I actually support all types of programmers, from hackers to black hats to white hats to all different types of programmers. I don't care where you come from. Now, there is a limit, right? But it's not my place to judge. It's none of my business. With that being said, we talked about activations, functions, and now we're going to talk about mathematic arithmetic needed to even know how to create a artificial neural network, or better known as ANN, capital A, capital N, capital N. So there's 1, 2, 3, 4. I want you to put up your hand in front of your face and put up 4 fingers. That's how many arithmetic operators you're going to need and to learn and study if you even want to get into the stuff. If you know addition, you're good. If you know subtraction, you're good. If you know division, you're good. If you don't know exponentiation like me, I haven't really finished high school. I'm a high school dropout, believe it or not, and I don't care if I say that on stream. I'm very open about everything. I'm in my process of actually getting my education back, and for obvious reasons, you know, things are really hard. If you go to public school, you should know what I mean by that. Dealing with people and stuff like that. Come on, I'm a nerd. I like computers. What do you think's gonna happen? So, with that said, if we look here, exponentiation, and let me see if I'm saying this word right. Exponentiate. I don't know how to say this word.
Exponentiation.
Exponentiation. Exponentiation. Okay? That word. Okay? So exponentiation. So you guys know, so I'm gonna show you guys some inspiring things. Okay? I'm gonna show you guys something inspirational. If you don't think you can learn math, I tried for the first time learning exponentiation for the first time in a very long time, right? I don't study exponentiation. I don't fuck with exponentiation. And yeah. So I created the script in Visual Studio Code to actually practice my exponentiation. And I wanted to see if I can learn it. In a matter of 10 minutes or 15 minutes, you guys can look back at the last live stream, the one before this one. You can actually see me making this script from scratch, and it's literally me. Everything that you see right here, I calculated all this with my mind. You know, I kind of like off the dome, kind of just, it was strange because it kind of happened from something simple. I started, okay, so 2 to the power of 2 equals 4. And then, so I was like, all right, 2 to the power of 2 is just 2 times 2. And 2 to the power of 3 is just 2 times 4. And, you know, so on. 2 to the power of 4 is just 2 times 8. And then it just started clicking and clicking and clicking. I'm like, okay. And then I noticed something odd. I noticed the pattern that really struck me. If you pay attention to this, 4, 8, 16, 32, 64, 128, 256, 512, 10, 24, and so on and so on. And there's a pattern going on here. Not only that, with sample rate, 4-bit, 8-bit, 16-bit, 32-bit, 64-bit, 128-bit, 256-bit, 512-bit, 1024 bit. There's a pattern going on. I've seen this somewhere. Maybe I'm crazy. Maybe someone can explain it to me on my Twitter. My Twitter is GenesisGir, at GenesisGir. This is my Twitter handle. If anyone can tell me, this, actually, you know what I should do? I should just share my Twitter, link my Twitter instead of my handle, huh? But this is more so in the sense of, let me show you. Let me actually show you guys. First, I'm going to go explain this entire thing really quickly. Here's my Twitter. I'm going to drop it here. That's the wrong one. This one, the last one. Make sure to click the last one. So here are all the expressions. We call this expression. These are all the expressions right here. Right? And these expressions, all the way to the right are the actual answers that I came up with. So when I first started, it was kind of like this. It looked like this, you know? Actually, what it actually looked like, let's delete everything. This is kind of what it looked like. I started here like this, like a script like this. And I was like, okay, 2 to the power of 2. Okay. So 2 times 2, 4. And then that just became this, right? The brain is a remarkable thing. It blew me out the water. And please believe me when I tell you that this is not even that complicated. But the fact that someone with no knowledge of mathematical arithmetic could just get these patterns, and my brain start to be like, okay, that does that, this does this does this. It's like a puzzle piece is being put together. And this beautiful, magnificent arrangement. And this would probably look like really simple to someone who does this for a living, but I'm proud of it. This is my first journey into mathematics and arithmetic. And every time I would get it right, you know, without a calculator, by the way. The only times I used the calculator was to, you know, check to see if I actually got it right. So I would write down this arithmetic. I would put the expression down. I would put my answer and put it in. And I would open up this calculator called DreamCalc. I would say, okay, time to check to see if my answer was correct. So I would do 2 to the power of, I don't know. Let's actually check to see if all of these are right. So 2 to the power of 2 is 4. Wait, what does this matter? I'm a programmer. This doesn't have anything to do. Yes, it does. The way artificial neural networks actually, you know, one of the key components of artificial neural networks is math. It's math. How it computates these weights and these vectors. It is really super important to know this stuff, right? So that's 4. We got that right. And we move on. We go 2 to the power of 3. We get 8. 2 to the power of 4. We get 16. And then, you know, so on. And then 2 to the power of 5. We get 32. 2 to the power of 6. We get 64. Yeah, trust me on this. All of this is correct. I've done my analysis. I've rechecked it. And now I want to show you guys something that has shocked me. That was mysterious to me. Remember when I told you that 4, 8, 16, 32, 64, it reminded me kind of like a computer. Like you see it in computers a lot. If we go to my audio system that I'm using right now, my Focusrite, and we open it up, this is actually my audio interface. And inside of my audio interface, I get these options right here. The buffer size. And the lowest it can go is 16. But tell me if you notice something very strange. If we look over here, or very remarkable, 2 to the power of 4 is 16. the buffer size 16. 2 to the power of 5 is 32. We have 32 right here. 2 to the power of 6 is 64. We have 64. We have 2 to the power of 7. We have 128 right here. And then we have 160. Let's see if we can find 160. 256. So we go here. Look at the buffer size, 256. 2 to the power of 8. So that's 2 times 128. We get 256. It's amazing. It's remarkable. And then in the highest we can actually go, then we have 512, and then we even have the ultimate one, which is 1K 1024, which is 2 to the power of 10. So how this works, this audio interface works, is the buffer size, the bigger the buffer size is, the more latency and delay that you're going to get. So the lower you go down the buffer size, the more faster your input delay is going to be, the more faster things are going to go. I can go to 16. So with the 16, we get 5.1 millisecond delay, right? So I don't know. I found that very interesting. Yeah, I'm glad that I covered that here, because you can actually see this in digital audio workstations. If you guys don't know, like music production, some audio workstations will have buffer sizes to decrease the delay. The higher you put it up, the more delay you'll get, but it'll preserve, it'll stop the clicks and pops of digital audio workstations. And the lower you go, there is less delay, but if your computer can't handle that buffer rate, that buffer size, your computer will start to become stagnant. It won't be able to process all of the buffers coming inside of it. So that's where we start getting the lag being introduced. So mathematics and arithmetics have a huge part to play with computers as well, and everything software related. So you tell me if you think that math isn't important. It is. And it's not really that hard, because as long as you study this stuff and you take your time to study it, you should be fine. I'm going to play some music now. Play some calm music. So, what else do we have here? So we went through mathematical arithmetics, we went through activation functions, and this is the whole sense of neural networks, artificial neural networks. We're going to talk about something new. Let's see. All right, so remember when I was talking about non-linear transformations or transformations in general? I'm going to read this documentation for you, and you make sense of what you think this means, okay? Non-linear transformations are mathematical operations that alter the relationships between inputs and outputs in a non-linear manner in the context of neural networks. Non-linear transformations are applied to the inputs and intermediate representations to capture complex patterns and relationships that are not expressed or modeled by linear transformations. Linear transformations preserve the linearity of the relationship between inputs and outputs. In a linear transformation, the output can be obtained by multiplying the inputs by a constant scaling factor and adding a bias term. This results in a straight line or a plane in a lower dimensional in lower dimensional spaces. However, nonlinear transformations, on the other hand, introduce curvature and nonlinear shapes into the relationships between inputs and output. They can bend, twist, or deform input space in complex ways, allowing neural networks to learn and represent more intricate patterns and structures. Activation functions, which are, okay, so now we talked about linear and nonlinear transformations, right? So what are the difference between linear transformations and nonlinear? Linear, they aim to have results in a straight line, and nonlinear transformations, on the other hand, they're very complex, they're very intricate structures, and they both have different results. They're two different algorithms that give two different types of results at the end of the day when it comes when we talk about artificial neural networks and neural networks. Yeah, let's stay on key. Now, activation functions. What are they? Why do we need them inside of artificial neural networks? Why do we need them? Well, I'm going to read this documentation. Activation functions, which are applied to the weighted sum of the inputs of each neuron, are one of the primary examples of nonlinear transformations in neural networks. Activation functions like sigmoid, remember the one with the S? I think this is rectified. The rectified LU and the TAN introduce nonlinearities by mapping the input values to nonlinear output values. This enables the network to model nonlinear relationships and capture more complex patterns. So, in a way, these activation functions are capturing complex patterns and the functions themselves. Nonlinear transformations can also be introduced through other components of neural networks, such as convolutional layers, pooling layers, reconcurrent connections. These components perform nonlinear operations on the input data, allowing the network to extract and learn higher level features and representation. So features, what do features mean, right? In a whole grand scheme of ANN, features are the actual features that it has identified within these inputs, if that makes sense. It's the, the features. It's exactly what it's self-explanatory. In summary, nonlinear transformations are mathematical operations or functions that introduce curvature or nonlinear shapes into the relationships between inputs and outputs. They are essential in neural networks to capture and model complex patterns, enabling the network to learn and represent nonlinear relationships in the data. So, nonlinear transformations are mathematical operations. They're mathematical functions, kind of like a function inside of Python or C++ or Java. These functions contain a strategy, a method, a mechanism to get these complex patterns to represent the relationships with the data that it's working with. So, remarkable, right? Now there's non-linearities. I think this is okay. We can talk about that. And then we have perceptrons. So let's actually pull up an image here. We're going to look up neuron in brain. So here we have an image. We're going to find an image of like a human brain. I don't know. So take a good look at this picture. So you see those little yellow dots? Those are neurons. And they're located all over your brain. All over your brain. And when we talk about artificial intelligence and their neural networks, they have these little glowing dots too. They have neurons too. There's a specific term for what we call neurons when in the terms of ANN or AN. We call them perceptrons. It's the same thing, or you can call them artificial neurons. Artificial neurons, or neurons period, hear me out, are just data transmitters. They transmit data. That's what they do. They transmit data back and forth to one another, and they come up with a prediction off of these mathematical operations, as we know, activation functions and stuff like that. So why is this crucial? If you did not have a neuron or any neurons in your brain, you would probably not be even looking at your phone right now. You'd probably wouldn't know how to walk to your door. You wouldn't know how to complete day-to-day tasks, right? Which brings me back to this topic here. So what is a task? A task can be anything. Going to your computer, turning it on, getting up, moving your legs about, standing up, moving backwards, moving forwards, looking around your room. These are tasks. And the way that we actually implement these tasks, we have to think neurons for that, because that's kind of how that works. Great. Now that you guys know that, let's move on. So there's different types of neurons inside of artificial intelligence. There's a single layer and there's a multi-layer called MLPs. There's a lot of other types too. They're just not just one or two. There's several. That I've learned so far, there's only single. If you're getting into artificial or AI right now, all you need to know is that there is the single perceptron and there's the MLP perceptron, also known as the multi-layer perceptron. And this handles data a little bit more. It can do a little bit more complex tasks because it has multiple perceptrons going on. So let's go take a look. Types of perceptron. Single layer. Single layer perceptrons can learn only linearly, like in a straight line. Right? I want to drink some water right now. I'm not going to lie. My mouth is getting dry. And then we have multi-layer perceptrons. They can learn about two. Multi-layer perceptrons can learn about two or more layers, having a greater processing power. So obviously, the more neurons you're working with in tandem, the more stronger your processing power is going to get, right? More neurons mean more yay, more power, more push. There's single layer perceptrons and there's multi-layer perceptrons. Let's move on. So what are perceptrons in the grand scheme of machine learning? Well, the most common, I'm going to read the documentation right now. The most commonly used term in artificial intelligence and machine learning is artificial intelligence machine learning. That's what that means. It is the beginning step of learning coding and deep learning technologies, which consist of values, scores, thresholds, weights, implementing logic gates. Perceptron is the nurturing step of an artificial neural link. In the 19th century, Mr. Frank Rosenblatt invented the perceptron to perform specific high-level calculations to detect data capabilities input data capabilities or business intelligence. However, now it is used for various other purposes. The history of perceptron. The perceptron was first introduced by Frank Rosenblatt in 1958 as a type of artificial neural network capable of learning and performing binary classification tasks, Rosenblatt was a psychologist and a computer scientist who was interested in developing a machine that could learn and recognize patterns in data, inspired by the workings of the human brain. The perceptron was based on the concept of a simple computational unit, which takes one or more inputs and produces a single output. Modeled after the structure and function of a neuron in the brain, the perceptron was designed to be able to learn from examples, which are data sets, adjust its parameters, and improve its accuracy in classifying new examples or predictions. The perceptron algorithm was initially used to solve simple problems such as recognizing handwritten characters, but it soon faced criticism due to its limited capacity to learn complex patterns and its inability to handle a non-linearly separable data. These limitations led to the decline of research of perceptrons in the 1960s to the 1970s. However, in the 1980s, the development of the backpropagation, a powerful algorithm. And an algorithm is just a way that you can do something. It is a strategy, it is a method, it is a mechanism, it is a style, it is a way to do something. Right? Where did I leave off? Training multi... Okay, a powerful... Okay, so... However, in the 1980s, the development of backpropagation, a powerful algorithm for training multi-layer neural networks, renewed interest in artificial neural networks and sparked a new era of research and innovation in machine learning today. Perceptrons are regarded in the simplest form of artificial neural networks and are still widely used in applications such as image recognition, natural language processing, and speech recognition. So, as you guys can see, what they're trying to say is, this is used in a lot of the technologies that we use today, like phone recognition, maybe like voicemail recognition, speech recognition, stuff like that. Have you ever thought to yourself when you're calling a company on the phone and it tells you, hey, if you would like to talk to an executive, please say talk to an executive. Talk to an executive. That's an input that you're sending it. They're probably working with some type of artificial neural network, or they have their own neural network that's actually compiling that data, or a program that compiles this data and is actually taking that input and making sense of what that desired output should be. So if I say talk to a supervisor, it doesn't matter how I say it, it's going to recognize the pattern of talk to a supervisor, and it's going to do whatever it does then. Does that make sense? I hope you understand this. If you already understand it, then good. Luther. Oh, hello, Luther. Welcome. I'm not really paying attention to chat right now, but I will go read. I don't know why I'm not getting messages again. But there's that. I will read messages. I do have to leave very soon. It's 11 for me. I'm gonna end stream at 11:30 because I have somewhere to go. I have somewhere to go today. I have to go to an appointment today. So, what is the perceptron model in machine learning? So what is the perception model in machine learning, right? What is it? A machine-based algorithm used for supervised learning and various binary sorting tasks is called a perceptron. A machine-based algorithm used for supervised learning of now I can see your text. There we go. I can see your text, buddy. I can see it. So a perceptron is just a algorithm. It's an algorithm that makes sense of its main purpose is to learn. That is what it does. Artificial neurons are made to learn. Now, some people cut off the music. We got to get serious. There are so many skeptics out there that will say, oh, all that artificial stuff is all hocus pocus. It's working off of this. It's working off of, flow control and all that stuff. Humans are telling you what to do. No. No, not at all. These neural networks, these AND systems are actually learning over and over and over and over and assessing data and getting better, getting smarter, getting a better understanding, putting the false negatives and the false positives to the side, getting a deeper, imagine a magnifying glass. I want you to think when an artificial neural network is first born, it's like a baby. It's like a child. It doesn't really know about. Sometimes it takes months to maybe even years to get a good working neural network to even get going. Maybe months, maybe, right? Or maybe like it does. I don't know. I don't know the time span, but I do know it does take time for this, whatever you're trying to make it do. Because it's like a baby, in a way. And it's actually learning, and the way it learns, how fast it learns, depends on how well high quality code has been written and how fast it can have a deep understanding. What if I told you every single artificial neural network learns differently in its own discrete way? Not every artificial robotic is AI is important. Yes, it is definitely, exactly. So I'm going to read this comment from my buddy here. He said, I have a goal now, study AI and robotics. And it is interesting and importante. It is important. That's if you want to get into that. If you are just a web developer and you're just a developer who wants to do just, eventually you're going to want to work with artificial intelligence at a point, or with neural networks, right? You want to, if you're going to be making a Google email site, you want to differentiate spam email from good email, from normal email. So you'll actually need an artificial neural network. There's going to be one day that your boss will come up to you and he's going to say, hey, we need a system to detect if spam emails, fake emails and real emails, stuff like that. Can you make it for me? Oh yeah, I can cook you up a quick little neural network that can take care of that. I won't have to check it all the time. No. It'll do everything. It'll take care of it. That is what people want. People want things that are efficient. And imagine, there's like GitHub Copilot. I have it on my thing. If you guys don't know what GitHub Copilot is, it is essentially a GitHub Copilot. So GitHub Copilot, you see how it's writing all this on its own? It's using a neural network. It's using an artificial neural network to make suggestions of code. Yeah. It's insane. It's amazing. It's how it works. We go down. Go a little bit down. Obviously, you have to pay for this. I myself, I don't use GitHub Copilot. I'm just joking in all of my bios that I use GitHub Copilot to write all my code. I write all of my code. Lol. So I don't write all my code with GitHub Copilot. But it is a good tool. It is nice to use sometimes. I might actually get GitHub Copilot again. It is nice sometimes. Get an AI-based suggestions just for you. So how this works, I'm thinking there's probably a huge data set of a bunch of code, a repository of a bunch of code that this artificial neural network has access to that can, make comparisons and do all its type of, analysis, and that's why it has the predictions that it has and the suggestions that it has. Okay. Let's put some music on. Continue on. It's officially 11. I have to leave in about 30 minutes. But I will be back today and I will stream for the rest of the day. Maybe for like 2-3 hours again. Who knows? 3 hours. We'll see. But also, let me just make this very clear. I am officially not going to be on Twitch anymore. We have officially moved over to YouTube. So if you guys wonder why I don't stream on YouTube, I mean on Twitch, we officially moved over. That is the good news. The bad news is I won't be streaming on Twitch anymore, but it's okay. You know, Twitch is behind me. It's just Twitch for me. And here are good points why not to stream on Twitch if you are a starting content creator or whatever. One, the categories are very small. The communities are very based and very small. Once those 1,000 people have assessed and made their assumptions about you, that's not going to change. They're going to avoid you at all costs if they like you or not. And guys, the software development category does not like me whatsoever. I don't know why. You guys should go ask them. I think it's because I know why. Because when I was younger, I would literally be a Mr. Know-It-All, you know? Like, people would be mean to me, make fun of me, and then I would challenge them. I would be like, okay, well, if you know so much, come test me on my knowledge. And then I would pass them a live share code, and they never would show up. And the people who did show up, I actually proved them wrong. So yeah, they kind of don't like me because I'm a little script kiddie. No, but I've met some cool people in the Twitch categories. Zion, I've met Olek. What's another one? Version. He was really cool. A lot of other cool people. So I'm not gonna say the entire category was bad, but I'm officially moving to YouTube. So if you want to watch my streams now, it's YouTube exclusive. With that said, let's move on. And Poflo. Yes, Mr. Poflo. You are in my bag of goodies, okay? So let's move on. Let's see. Probability. So what is probability? Do you guys know what probability is? Poflo, do you know what probability is? If I tell you top 2. Yeah, exactly. But who knows what probability is? Do you know what it is? So if I say the probability of it raining today is probably really high. You guys know what that means? Yeah, I think so. Right? So an example, I said, yo, Mrs. Genesis and Luther, the probability that I might make a stream today is very low. What that means, probability is simply how likely something is going to happen. Right? So whether something, the chances of something happening or not. So if I say it's probable that I might go to the movies today, it's possible that I might go to the movies today. The probability of me getting an award is very high. The probability of me watching Stranger Things today is very high. What does this have to do with AI? Because AI works with probability too. Did you know that? Well, now you do. That's why I put that there. Problem domain. Now we're going to talk about problem domain. What is problem domain? This is really important. So, problem domain. What is it? When you first decide to create an artificial neural network, right? The first thing you say in your head, what is going to be the problem domain that I want this artificial, this ANN to do, Do I want it to detect dogs in images? Do I want the problem to be like if I was creating a robot, right? The problem domain is that I want this robot to, the problem is that these boxes must be picked up. That is the task. The task is to pick up the boxes, but the problem is that these boxes are, you know, we need to pick them up. So that is the problem domain when we mean something like that. So when you first decide to make a neural network, you have to decide what the problem is that you are trying to let your artificial neural network achieve and complete. Then we come to regression. Regression in the context of artificial neural networks, or ANN. I'm not going to say artificial neural networks all the time. I'm just going to call them ANNs from now on. Can we do that? Because saying artificial neural network is really, you know, it's making my throat hurt. So we're going to call them ANNs. Regression refers to the type of learning task where the goal is to predict a continuous numeric value or set of continuous values as an output. Regression in ANNs involves training the network to learn a mapping between the input features and the corresponding target values. So let's just stop there. So if we go over here, here are some key components involved in regression. Input data, the activation function, the loss function, the training, the evaluation, right? This is the regression. Let's move on. Okay, let's see what this is. Secretion. Okay, I'm going to try to find things that are very important. Okay, semantics. What is semantics in the meanings of programming? So semantics means the study of the meaning of something. So the study. So if I literally sit here and I say, hey, we need to figure out the semantics of this whole situation. We need to figure out the truth. What is the meaning? What is the importance of this situation? So if I was playing a video game and I sat there and I was talking to my teammates and I said, guys, we're sitting here just talking on a mic and you guys are talking about smoking weed and just sitting there just like, what is the semantics of this whole situation? What you're really saying to those people is, dude, what's the whole point of this? What is the meaning of this? What is the semantic of this? Right? Hopefully that makes sense. The probability to become human is 0% because I'm 100% cat dog. Wait, do you mean this? Do you know what this show is? Cat Dog? You know there's a show called Cat Dog, right? Where there's it's a dog and a cat that are they're together. Cat dog, god diggity dog, cat dog. I don't know if you know about this show. It's a cat and a dog. They share the same body. Oh yeah, so you see this all the time? So you like this show? I like this show too. This show's really nice. I used to watch it when I was a kid. Cat Dog is really nice. It's a nice show. Cat dog, hot diggity dog, hot dog, na 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 na. Yeah. But so that's what semantic means. It's the study of meaning in language. Now, there's something that I do. We're almost getting to the end. We're learning all this stuff now. After I explain SVM, after I explain TensorFlow and vectors, maybe like all this stuff down here, I'm not going to go through all the stuff because again, guys, you guys have to do your study on it too. I mean, what kind of live stream would it be if I broke down literally every single thing I mean, would you guys really want to sit there and listen to me talk about like artificial intelligence stuff all the time? Like, Sorry. He was calling me. So I'm gonna go ahead and turn this off. So SVMs. What are SVMs? So SVM means support vector machine or machines. It's a support vector machines. And it's a way of a supervised learning, right? So let's go see if I know what I'm talking about. Let's go see. Hopefully, I hope I get it right. SVM is a supervised machine learning. Yep, we got it right. So this is a part of artificial neural networks and supervised machine learning algorithms. What does this do? What does this support vector machine do? What is its job? Its job is to solve both the regression problems and the classification problems. The SVN finds a hyperplane that surrogates the labeled dataset supervised machine learning into two classes. So just think of this SVM machine. Its long-term goal is to solve the problems between classification and regression. And we talked about what regression was. Regression was the whole process. Let's go back over there and go see the whole process of, like, you know, input data. Input data, network architecture. I'm not going to read through all this stuff here because, I mean, hopefully you guys have been watching the streams and paying attention. Activation functions, you guys know what that is. Loss function, training, and then we have the all of this right here. These are all the key components of the steps involved in regression. This is a regression. All these steps going on: the input data, the architecture, the activation, the loss function, the training, and the evaluation that gives the predictions at the end of the day. These are the steps of what goes on inside of a neural network. And even your brain too. By the way, these remember, because artificial neural networks are copied from, are reverse engineered from human biological neural networks. Okay, we're getting near the end. Okay, 10 more minutes. We are on time. Hopefully you guys are learning something new. And I'm learning a lot too. So TensorFlow. Do you guys know what TensorFlow is? Who knows what TensorFlow is? If you don't know what TensorFlow is, I'm going to tell you right now. TensorFlow is a Python module, not just a Python module. It is a library. It is a third-party module that was created for machine learning. It's great for creating and facilitating, as it even says it here, facilitate and developing your own machine learning models. That's right. If we go over here and look up Tensor, if we look up TensorFlow, we can see that they have their own website. Create production-grade machine learning models. You can create your own machine learning models. So, guys, I don't want to hear that, oh, man, I don't know, it's too hard for me. It's possible. Get your feet wet and all this stuff. And look what's going on here. He's taking a picture of a dog. The dog has a bounding box over it. That's what they're called. The detection boxes are called bounding boxes. And you could see that the dog is being found. And this is with the help of TensorFlow. Prepare data. It says use models and tools. Here, I'm going to link this to you. Link this to anyone curious. You can build machine learning models, use pre-trained models, or create custom ones. As you can see, you can create custom ones. So TensorFlow allows you to use pre-trained models that are already created. And you could actually look inside of those pre-trained models and see how they were built. Or you can create your own custom ones, right? I think there's a part here where you can create your own custom one. Let's go see. Fine-tune them on or customize them to perform new tasks. I'm going to go ahead and bookmark this shit. So just know that TensorFlow And I should have TensorFlow installed. Let's go see. Let's go into a random module. Let's see, import TensorFlow. There you go. I have TensorFlow installed, and as you guys can see right there, TensorFlow, top level module of TensorFlow by convention. The primary function of this model is to import all the public TensorFlow interfaces into one singular place. The interfaces themselves are located in submodules and described below. But as you guys know, this is for machine learning. So you could use, there's other things used for machine learning. There's Keras, there's Pandas, there's all different types of other machine learning modules that you could use. Let's see. Let's go over here. All right, so here's a bunch of commonly used functions in OpenCV. Pause the video here if you want to go ahead and take a look at that. You guys will see me using these, right? I've practically used all of these. I think the only ones I haven't used yet is the circle one, put text, line. I haven't used that yet. I haven't used this one. This one. I haven't messed with the image manipulation ones. I've used threshold. Yeah. But I've practically used all of these. Yeah, all of these I probably used. Okay, vectors. What are vectors in a sense of machine learning? So here are a few key uses of vectors in ANDs. There's input vectors, there's weight vectors, and there's bias vectors, and there's output vectors. We could say a weight vector. Now, remember, let's talk about neurons really quickly. I'm going to be talking really fast, so please try to compute this as fast as you can. We're going to go over here to, okay, let's go, because I'm running out of time. Let's look up neurons. And I apologize, when I come back, there should be more time. Okay. Let's go see if we can find an example. Here we go. Okay. So you look at this image here. This is a neuron. The space between this is the presynaptic neuron, and this one over here is the postsynaptic neuron. The presynaptic neuron is responsible for sending the neuron transmitters, and it goes through this as you can see, the neuron transmitters. You see these little dots here? That's actually the information that the neuron actually stores. Remember that. This is really important. So in the sense of, you're probably like, what does this all mean? It's so confusing. I know it's confusing, but it makes sense. I'm telling you. Because if you're wondering, well, okay, what you're trying to ultimately accomplish is make something that almost is close to life, that can computate and move data around on its own, to have a mind of its own in a sense, right? And it needs to go through these mathematical computations, these processes in order to do that. So this one over here, this is the axon. This is the end of an axon terminal. And these little dots that you see here, I'm going to zoom in. These little dots are the actual information. They're the neuron transmitters, right? And this isn't a biological, but we've reverse engineered it so it's an ANDs too, right? And then it goes through this fusion, and it fuses with the membrane of the actual presynaptic neuron. It'll fuse, and when it goes through this fusion, you see this thing going on. It's boom, boom, boom. Here's all the stuff. It's all accumulating, and then it's going to fuse with that presynaptic. Presynaptic meaning the predecessor of the postsynaptic neuron. It's going to fuse. All of that data is going to be released, and that's, look at that. It's going to be fed to the receptors of the postsynaptic neuron. It's going and this receptor is lying on top of this membrane here. And then now look what's happening here. Let's see. We're getting a lot of what the heck is going on? There we go. Sorry. Don't know what happened there. So all these neuron transmitters get fed to the receptors, and this is kind of the butt of the neuron, with the receptors going num 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 num. It's eating all of those juicy, all that data. Now I know what you're thinking. What if one of these neuron transmitters get lost? What if they get lost, or what if they get somewhere else? That's a good question. If one of these neurotransmitters, or several of them, do not make it to their receptors, they actually break down. They break down. And by the way, this process that's going on of the fusion is possible because of the calcium ions. This is something called fusion. I forgot what it's called. Let's just call it fusion for now. But this is ionization. There's an ionization going on in this process that is letting that capsule, this versicle, because if you think about it, this is this circle that is containing. I'm sorry, I'm talking so fast, guys. I got 1 more minute. I gotta leave out in 1 more minute. These circles that you see right here, containing all these red little dots, these are called the synapse versicles. Their job is to contain all of the data inside of them, and once they come over here and they fuse through the ionization of calcium, they release all of the data, all of the neuron transmitters, and they go into these receptors, right? Now, why does this matter? It matters because this is how neurons work, right? Here's the whole structure of it. Like, look, here's the dendrite, here's the soma, here's the axon, and here's all the axon terminals right over here. Right? Over here to the left. It's remarkable. It's amazing. Now, remember when I told you if some neuron transmitters do not make it to the end goal, they don't die. They actually break down into protein. So the brain can reuse this source to make more neurons and make more to redo the process. If this did not exist, if this reproduction of neurons did not exist, we would not be alive today. We would actually be dead. So, yeah. Amazing, isn't it? Something like this is actually keeping you alive, right? So it's almost like recycling. It's recycling all the broken down neurotransmitters that don't make it through and all that stuff. Okay, great. And I think that'll conclude the stream for today. I'm sorry that I went really fast at the end, but hopefully somebody learned something. I'll be back soon. Need to clean room. Okay, I probably won't be here. I'm gonna be gone. But I'll catch you later, Luther. I'll catch you later, guys. I have to leave because I have to go to an appointment right now. I'll catch you guys later.